So this video is going to give you guys a couple hints on the homework for chapter 2 for the class. Two things before we begin. First, I'm recovering from a cold, so I'm sorry if my voice is a little bit scratchy. And then secondly, I want to make sure that we know how important chapter 2 is. A lot of statistics does talk about graphical analysis of data and variables, and this is kind of the building the foundations for what the rest of the class is going to be about. So making sure that you really understand these concepts of graphs is really important moving forward in the class. There's 3 problems that I want us to do out of the homework set for chapter 2 in the video, because the problems are kind of paired together in a way that they're similar. So for example, in the first section, there's question 2.4 and question 2.6 in that section of homework. And for the video, I'm going to go over a couple things in 2.4 because 2.6 is very similar. Okay, so in part A, they want you to make a frequency table. And there are 3 different outcomes that you can have in this survey. It said that there were 40 adults. Maybe let's write that at the top. So our sample was 40 people. Okay, and the responses are good, bad, and indifferent. So I'm going to write that here. Good, bad, and indifferent. And what part A wants us to find is the frequency table. Okay. Now, the thing about the frequency table, frequency is just a fancy word for number of times. Okay. And in our frequency table, the one way we can check our answer in the end is this column should add up to our total of 40. Okay. And so I'm not going to go through the actual answer for part A, but one thing I do want to show you in the book with pencil is I went through and kind of counted all of the goods, all the G's, and then I went through and counted all of the B's using like a different mark, and that was really helpful for me to go through and count to create that frequency distribution table. And just for sake of example, I will say like G, there were 14 G's because we're going to need to do some examples here. Okay. And then in part B, it wants you to find relative frequency. Okay, that's going to be the decimal. And it wants you to find percent. So relative frequency is 14 over 40. It's going to be 14 over your total. The number of times that variable happened over your total is going to give you your relative frequency. And then to find the percent, you just move the decimal twice. So this gives us 0.35, which means our percentage is 35%. And in my key, when I was going through this problem, I just did A and B side by side like this because it was easy for me rather than like recreating the table to then just be able to see this. Ways to check your answer to make sure that you're doing it correctly, especially when we're counting, because sometimes like even I counted wrong on 2 of the problems when I was doing the answer key and had to go back and check. So the way to check to make sure you're doing this correctly is this sum should add up to 1.0 and this sum should add up to 100%. Okay, you don't need to show that work for like justification pieces. I'm only telling you that because it helps you make sure that you have the right answer. And so it's like a nice check for understanding while you're doing it to make sure you're doing it correctly. Okay, C, you can just use the percentage table here to find C. It's pretty straightforward. D, what percent of the adults in the sample, so the building said building casino, sorry, is bad or we're indifferent. So you're going to look at the bad percentage and the indifferent percentage, and you're just going to add those to get the percent here where C was good. Another way that you can look at part D is bad and indifferent is the exact opposite of good. Like our variables have no overlap up here. And so you could also just do 1 minus the percent that said good, and it should give you the exact same thing on part D. Okay, it's called the complement. You probably haven't learned that yet for probability speaking, but that's what it's called. All right, on part E and then the rest of the graphs, which is why I wanted to do this problem. One thing that's really important is to make sure your y-axis on this graph is exactly what they're asking for. So on E, it says draw a bar graph for the frequency distribution. So even though the bars would look the same, okay, if I want to draw the bar graph for a frequency distribution, then I'm going to make sure that frequencies is what's on my y-axis, okay? And I would make sure that I label appropriately here. And then my variable, okay, goes here. So this is going to be response. Now, unless we're doing a Pareto chart, which we do that in part G, it doesn't matter the order in which you put categorical variables because they're just categories. So you could put just exactly like this, good, bad, indifferent. And I'm fine with you on your homework just using the abbreviated pieces here because those variables were defined in the problem. So if they're defined in the problem, you should be able to use them on the homework. Okay, that should be totally fine. All right, F, the good old pie chart. Let's see how good of a circle I can draw. I always screw up here. Okay, that's pretty good. So the thing that I always go for on my percents is like, is there one that's either like 25 or 50% that's easiest to draw first? I usually draw that in first. So like 35 is not 25, it's bigger than that, and that's the only one you have with me right now, so I'm going to have to use that one. So 25 would be here, would be a quarter, right? Because the whole thing would be 100%. And so I'm using my percent table here. Okay, that's why it was really nice in A, B here that they had us do all this, because then you could use that for the problem. So if this is 25, 35 is going to be just a little bit more than that, right? And then on part G, it says to make the Pareto chart for the percent distribution. So it's going to look similar to E, but you're going to do percentage on your Y. Okay. And then remember for a Pareto chart, response order needs to be in decreasing. So whichever percent is the highest needs to go here to the lowest. That's what makes that chart different, okay? And then again, 2.6 is extremely similar. I'll just give a little shot here underneath the dot cam, okay? 2.6, it's how people pay at a supermarket, okay? But very, very similar. All right, the next section of problems are in 2.2, and I want to go over question 218. Okay. Okay, so question number 218 is what I want to do here. Okay. Sorry, I'm trying to find it here in the book, so I have it for reference. Okay, so on this problem, and it's similar to 214. Okay, it's just 218 had a little bit more to it, so I wanted to do the one that was actually a little bit harder. You're welcome. So all the problems on this page, it's on page 59 in the book, have to deal with this huge broken up list of participants. And so there's 30 male and 30 female participants, and they get this data from them, and it looks at their blood glucose levels, okay, which is what we're going to look at in 218. So here's the first half of the data, and then here's the second half. It's like split on the page, okay, like that. All right, so in problem 218, it wants us to look at the, it wants us to look at the frequency distribution table for the males, and it wants us to use these classes. So, okay, it already told us that there were 30 males. So I'm gonna write N as 30 just so that we have that to check, right? We like to have that checking. And then the classes that it wants us to look at is 75 to 89, 90 to 104, 105 to 119, 120 to 134, and 135 to 149. This one's a little bit trickier than the categorical variable because just the way they gave the data is just really super icky. So I would suggest that you do like a tally system here and then write the frequency next to it. I just think it's going to be easier to organize the data that way. And so what I did is I went here, and so like the first male blood glucose level was 140, and then 106, 93, 92. You can see that. And so under 140 in that classification, I just put a little tick mark there. Okay. Under 106, I went under that classification and just put a little tick mark. And then like 93, 92, so on and so forth until I had all 30. Okay. Like that. Again, just for the sake of an example, I will give us that frequency, and that first one is 5. Okay. Oh, and speaking of 5, this always surprises me. When you do tallies, okay, there is a way to group them in 5 so that they're easier to count. Once you get to 5, you should cross it. Okay. I've had students when I've taught this class in the AP statistics in the past that just like keep trying to do marks, and then you got to count up all the marks. Whereas when you get to 5, if you cross it, you know that's a group of 5. It just makes counting go a lot faster. So I just want to make sure I give you that little tidbit there. And then again on B, it wants us to do relative frequency and then percent. So relative frequency would be 5 out of 30. Okay, and 5 out of 30 gives me 0.16 repeating. So we'll just do 3 decimals here, which means my percent is 16.7%. Okay. And then again, you can always check your answers by making sure this column adds to 1 and this column adds to 100% every single time. Now, when we construct the histogram here on part C, we're going to use, it says specifically for the percentage distribution. Okay, so percents has to go on your y-axis for here. And since this is a number, okay, it's a quantitative variable, we're going to put glucose reading here. And I'm going to treat this like a number line. So unlike the categorical data that we did on the first example, on this example, you have to use this as a number line, and you have to go in this order, okay? Now, you don't have to include 0, okay? And you don't even have to do the little break sign that like your Algebra 1 teacher maybe taught you. Just start with 75. Okay, 75, and then the next bin starts at 90. The next bin starts at 105, 120, 135, and then I'm also going to include 150. Now, there won't be anything over here, okay? But this bin from 135 to 149 will go up and over and then connect to that 150, okay? Piece, that's how histograms are going to work. And so when I go ahead, let's say, I don't want to throw you guys off. Maybe if you do like this is 10 and this is 20 here. So 17-ish%. I'm going to put my bar like this. Now, everything in this bar, even though it touches 90, this is the numerical category 75 to 89. So it's all the way up from 75 to 89.9999999, which I think we're only talking about integers here, but it goes all the way up to just to 90. And then 90 to 104 is this next bin right here. Okay, but again, you want, because it's a quantitative variable, you want that number line across to be fluid, okay, just like a normal number line. On part D, if I'm looking at what's the probability that we're greater than 119, I'm going to look at my table right here, okay, because that would be everything greater than 119. And then E, the cumulative frequency, cumulative relative, and then cumulative percent. So here are my categories. All right, and then this is going to be cumulative. Cumulative means we're going to add, okay, everything before that. So everything in this first thing, whether it's frequency, relative frequency, or percentage, is going to match the line here. So 5.167 and then 16.7%. Now, in order to actually do this, I'm going to have to give you guys a little bit more, darn it, in order to explain this a little better. All right, so I'm going to add in here, this is 7.233 and 23.3%. Okay. So how this works is the next row is everything that or smaller. So 104 or less. So I'm going to actually add these two pieces to get 12. I'm going to add these two pieces here. What would that give me? 40, so 0.4, and then 40%. Okay, so it's now 12 people are at this benchmark of glucose or less. Okay, I'll give you one more, reward you for watching this video. So if the next frequency is 8, okay, so that means the next cumulative frequency would be 12 plus 8 gives me 20, because 20 people have a glucose, males have this glucose level of 119 or less. And so that's what the difference is between the cumulative frequency chart and the regular frequency chart. Cumulative means up to this point, how many people are at this level or less. All right, the last problem in this video is going to be problem 2.28. Okay, and this is for us to look at a stem and leaf plot, and there's 3 stem and leaf plot examples here. So 2.28 is the one I want us to look at. Okay, and so the stem and leaf plot, how this works is your tens place goes here, and then your leaves are your ones place. Okay, and so you want to make sure that you include all the tens. So any of these numbers here, like 5, 8, 3 here, those are all going to have 0 as their tens place. And you want this to be a number line, okay, straight down. So you're going to start with 0, 1, 2, 3. I don't think there's any 40s. No, okay, so we're going to have that like that. And then your leaves have to go in order. And this is where it gets to be a little bit of a pain. So I'll do the first leaf with you here. So I'm going to list up just maybe off to the side here, all the ones. So I have a 5, I have an 8, a 5, 2 3s in the next column, 9 and 8, a 6, and a 5. Okay. And I prefer, personally, it's totally up to you. I prefer finding the numbers going down the rows or down the columns, because it's less numbers to look at. So I think that's a little bit easier to look at it like that. So that's all the tens place of the 0. And now I need to order them. Be very careful when you do this. You want it to be very systematic because you want to be able to actually compare the different bins when you get here. So you have a 3 and a 3. We have 3 5s. 5, 5, 5. We have 1 6. We have 3 8s. And a 9. And then one other thing that I like to do is kind of off to the side, I like to keep a frequency count, okay? Because once you're all said and done, you should have your total number here, and then that way you can check to make sure you didn't miss a number. This is one of them that I missed a number. I missed the 6 when I made my answer key. Then I had to go back and erase a lot of things. Okay, and that's on part A. Now on part B, it wants us to split this, which is why I wanted to do this one. So the first leaf is going to be 0 through 4s, and the second one's going to be 5 through 9s. So you're going to take your original stem and leaf plot once you finish it, and then your tens place is going to have 2 of the digits, and it's just known in statistical graphs that you're splitting this from 0 to 4 and then 5 to 9, okay? Unless you say otherwise. That's just kind of what's known. So when I'm creating these leaves, anything from 0 to 4 goes in the first one, and then anything after that goes in the next one. So my 2 3s are going to go here, and then everything else is going to go in the second one here, okay? And you'll continue doing that. It is okay to have blanks. For example, you will actually have nothing here. There are no numbers 30 through 34 in the data. They're not there. So it's okay to have blanks. That's why it's important when you make these to make your tens like domain first, like it's a number line, then go fit the data to it. Because you don't want any skips in your number line. You want to be able to look at it. 2 things, and then I promise I'll be done with this video. When you take your stem and leaf plot, if you turn it this way, you now have a histogram, okay? You can make boxes around this data like a histogram. A histogram on this first one would have a bin width of 10. This would have a bin width of 5, okay? And so you could make this a histogram, and then you could actually see the shape, okay? I like showing students this because I think it makes a good visual for you. The other thing that stem and leaf plots, even though they're a pain to make, what makes them one of the best graphs is that it keeps the data values. Okay, when we create a histogram like we did on this first one, I no longer know what the values are in that bin. I know that there's 5 data points in it. I know that it's 17% of the data, but I don't know what the actual data points were anymore. I'd have to go back to the table to reference that. Whereas in a stem and leaf plot, you actually keep all the data values, okay? So again, pain to create because of the ordering aspect. They take a lot of time, but they're really valuable in that way that they keep the data there for you. I hope that was helpful in you completing your homework.